Today. You want to have your current electricity unit summary with you. We'll be adding a bit to that. The homework is up on the board, so you want to record that. You may get to it in class today, so you might just finish it up before the end of the day and not have to do it tonight. Anyway, what we hope to do today is create accurate circuit diagrams. So what you've done up to this point have been sketches and drawings, but we're going to be working on technical drawings here. What you're going to do is use a straight edge to individually draw diagrams of various circuits utilizing circuit symbols. And why we do this: gaining an understanding of the universal visual language of circuits will make representing them easier, because I know not all of us are awesome artists, and you don't have to be to do a good circuit diagram. So we're going to review some major concepts first, go over the activity that we did last week, and then get into the circuit diagram stuff. So here, I know you're sitting there probably with headphones with someone next to you, so you probably don't want to say this out loud, but just try to pause the video and quiz yourself. What do you understand about voltage? Well, just remember that voltage is electrical pressure, is one way to think of it, and it causes current to flow, and it's measured in volts. So it's kind of like the dam holding back water, or think of the water bottle with a certain amount of water in it. The more water it has, the more pressure it's going to have. Current, represented with an I, is the flow of electricity or electrons through a medium. It's measured in amps or amperes, but we'll just go with amps. Alright, so last week we did a little activity about how voltage would affect current. We built a circuit, we had two bulbs, two sockets, and the variable we were playing with was voltage. And we measured current in amps. We also measured the voltage. So here's a graph just showing some class results here. So if you look, we've got current running along here in amps, and one battery, which was around 1.5 volts. It was probably a lot less than that. But anyway, going across two bulbs, we had kind of about 0.19 amps or so. With two batteries, so twice the voltage, the current didn't get twice as strong, but it definitely increased. So if we think about the relationship between voltage and current, and you should have added this to your packet on page 2 where it says CE Activity 3 Summary, how does voltage affect current? To sum this up in the cleanest way possible, if you increase the voltage, you're going to increase the current. There's a relationship there. It's not a one-to-one relationship as we saw. So if you double the voltage, you're not necessarily going to double the current. But in a series circuit, you increase the voltage, you will increase the current. Alright, so moving on to our new stuff today, this big mess here. We are not going to do anything quite like this, but if you are trained to know what these symbols represent, this makes a whole lot more sense than a sketch that someone could do of a circuit diagram. If you notice some things here, notice that there are a lot of straight lines and right angles. A lot of these squiggly Charlie Brown shirt lines kind of scattered throughout here. We'll get to what that is. But we're not going to use hardly any of the things that you see here. We're going to be going way simpler than this. But I just wanted to show you this visual language that electricians and electrical engineers all have in common. So in circuit diagrams, we're going to use agreed upon symbols to represent a circuit. And the point is that electricians, electrical engineers, they have a common visual language, and you don't have to be an artist to draw these accurately. Alright, so this you want to record in your CE, your current electricity unit summary packet. If you go to page 2, you'll see a section that says Circuit Diagram Notes. And there's a box that says Circuit Diagram Symbols. So you want to go ahead and jot these in here. So a wire is just going to be a straight line. That's pretty simple to draw. You're going to be using a ruler when you draw these things here. A battery is this symbol, and this is on its side. So this is not standing straight up and down. That long line is the positive side of the battery, and the short line, and notice it's a little fatter. You don't have to draw it like that. That's the negative side of things. So you would have the wire coming out from the side. So actually, let me draw, and I've got a video coming here that I'll show you. But let's say you drew the positive and there's the negative side of the battery. The wire is going to attach like this, not over here and over here. But that's how you would show it. And there's your positive side and your negative side. So electrons were going to come out from this end of it. The way to remember that I use for myself is I think of the long line as being plus, it's more. Switch. So typically these are drawn in the open position. You can do it with the circles or in the video I'm about to show you. There are other ways to do it, and this is one way to do a light bulb, but there are other ways. So you have a little artistic license there and you get to choose what you want. So make sure you sketch these into your circuit diagram symbols. So some tips. You want to make sure all parts are connected. You don't want to leave any openings with the exception of the switch. Use a ruler. I'll be looking for you to use a ruler on these. These should be straight edges. Typically drawn with an open switch. And it's all drawn as rectangles or squares. There's all right angles in these things. So I'm going to have you try this one in a minute. But first, well, wouldn't be fair if I didn't at least show you a little bit about how to do this. So this is going to be a little meta, a little video within a video. Here's a little bit about drawing circuit diagrams. Doing artistic renderings of circuits like this are not really an efficient way of doing things. Electricians and electrical engineers use a common visual language to represent circuits they want to build. For our purposes, these are the symbols that we want to be using. Notice the wire is straight. There's no curves in our circuit diagrams. Everything's drawn with right angles. I'll demonstrate this a little bit later. The battery symbol looks like this. You don't have to draw the short line fatter. You can if you want, but you don't have to. To clarify, the long one is the positive terminal of the battery, and the short one is the negative terminal. And the wires would get connected here and here. I'll demonstrate that in a moment. For the switch, you could do it in a couple different ways. You can draw these little circles here. That's actually helpful. If you're drawing the switch closed, you can have those circles there to indicate there's a switch. Typically, though, you want to draw the switch open. It just is easier to tell where the switch is. Here's another simpler way of doing it, just without those circles. For the bulb, you have a few different choices to go with. You've got this circle with the X. This is supposed to be a circle, came out like a little bit like an oval. But this jagged Charlie Brown shirt kind of thing, I actually like that one personally the best because that jagged line represents a resistor, and a light bulb is a type of resistor. For you artistic ones, you can use this little curly-Q sort of thing here. So let's try to represent this circuit in a circuit diagram. We have two batteries leading around to the negative to a switch. If I flip the switch, hopefully on camera, you can kind of see that the bulbs are lit. And then we have two bulbs in series going around back to the positive end of the battery. So that's what I want to try to represent. I have two batteries, switch, two bulbs to try to represent an illustration. What some people find helpful to do is draw a square first. I'm not going to do that here because I'm doing this in pen and not in pencil. So I'm going to start with the battery. The negative, and I'm trying to replicate exactly what I saw. The negative was over on this side. So I'm going to draw there's one battery. And the other battery, I'm going to put right there. Now technically, I guess in my setup, I had a wire connecting them. But that's okay here. You can just have them next to each other. Someone could rebuild the circuit quite easily the same way. Notice the wire coming out is just straight. Now ordinarily I would be using a ruler here to represent this, but kind of just trying to save time a little bit. Even though this was technically one wire, in the drawing it does look like two, but it is just one wire coming here. Put the switch here. I'm going to draw it in the open position just so it's easier to see. So that's coming down there. And then over here, and again, this is now a new wire over here connecting to the switch. I'm going to put my two bulbs in. For me, I like to draw the resistor part first and then draw the circle around it, which I'll do in a moment. So no longer are we going to do artistic renderings of circuits. We're going to use these circuit diagrams to represent what we're doing in class. If you look closely, you'll notice that the only opening here is at the switch. All my corners are connected. I mean, this looks like openings, but those are just the battery symbols. But all my connections are clear with the bulbs as well, so you want to do that in your own illustrations too. Alright, so let's come back here. So, try this one out. Pause the video, and right there on your circuit diagram practice number 1, it's on your current electricity unit summary packet. Try it out. Alright, hopefully you've tried it out. You've used a ruler. There are rulers at the front of the room. Go get those if you haven't yet. Pause the video. If you haven't tried this, I want you actually trying this. Don't just copy here. So this is a pretty basic one. You got a battery and a bulb. That would be a circuit diagram for it. Notice that the short line is over here, matching where the negative is over here. So someone knows these symbols, they should be able to replicate this. So you could hand them this circuit drawing and they could make the circuit over here. Now, I know it's a little confusing. It looks like you have 1, 2, 3 wires over here and 1, 2, 3 wires over here. You don't. You only have 2 wires, one on each side. It's just how the visual language works for this. Here's circuit diagram practice number 2. Try this one out. It's very similar to the last one, only it has 2 bulbs on it. Alright, you're back. Hopefully you've paused the video, tried this out, used a ruler in circuit diagram practice number 2. That's what it should look like. Pretty similar to the last one. You have one battery. Notice where the negative and positive is. Notice where you have your bulbs. Here's circuit diagram number 3. Try this one out. Notice it has a switch in it. I don't have a sample of what this one looks like. Just pause the video, try it out on your practice. We'll look at it tomorrow. And here's a little wrinkle in it. This is circuit diagram practice number 4. It's got 2 batteries in it, a bulb and a switch. Go ahead and try to replicate this as a circuit diagram. Okay, so what you want to do now is take out your circuit electricity, CE activity 3. That's the one where we did voltage. How does voltage affect current? And we did some sketches. Below that, there's a box we have not filled in yet. And I'd like you to make circuit diagrams for the 2 circuits we made for that activity. You can hand in, when you're all set, circuit electricity activity 3 at the front table. I'll have a spot for that. And you can take a CE homework 2 sheet. That is some circuit electricity practice. Make sure you get that before you leave today. And we'll go over those tomorrow. And you can go ahead and begin your homework if you've gotten to this point. I'll see you tomorrow.